on opener 27. If I throw a ball at a rate of 64 feet per second from my window straight down. So I'm exerting a strong force on this. I'm whipping it straight down from my window 64 feet per second. And remember, we assumed my window was 16 feet high, which we referred to as our h sub 0. And now we're generating an initial velocity of 64 feet per second downward. So downward I'm going to regard as negative 64 feet per second. Downward. If it were up, it would be positive, because gravity, again, is pulling downward. So that's our negative direction. So graph the height of the ball with respect to time. Well, let me get an equation first and see what we can do with that. See if we can graph it. So I know I'm in feet, so g is 32 feet per second squared, and that's enough to get an equation. So h of t is equal to negative 1/2 times, let me write that out, negative 1/2 times my gravity constant times t squared plus my initial velocity, which is negative 64, so minus 64t, plus my initial height. And now I want to graph that, so let's simplify it. Negative 16t squared minus 64t plus 16. How do I graph this? Well, as you recall in the prior problems, we're putting it together. We can complete the square. And once we complete the square, we can graph it. So let's do that. I'm going to divide everything by negative 16 to get my a value to be 1. And I could have subtracted the c value first, but I decided to do this first on this problem. No specific reason. So plus 4t minus 1. How convenient those numbers are. So now I'm going to add 1 to both sides to get my c value to be 0. And now I'm ready to complete the square. So t squared plus 4t plus what equals 1 plus h of t over negative 16 plus what? Take my b value, cut it in half, square it, and I get 4. So 4 is the number I'm looking for. T plus half of b, quantity squared, must equal all this, so 5, 4 plus 1 is 5, plus h of t over negative 16. And for those that are getting uncomfortable with this h of t thing, well, that's function notation. It's really important to get comfortable with it, but h is the same thing. I'm just showing that the height is with respect to time. Time determines my height. So now getting h of t alone, I'm going to subtract 5 from both sides. So I get h of t over negative 16 equals t plus 2 squared minus 5. Multiplying both sides by negative 16, h of t equals, the first term becomes negative 16, t plus 2 squared. Second term, negative 5 times negative 16 is plus 80. So that is my vertex form. And I can graph that, because I know my vertex at negative 2, positive 80. I know my a values at negative 16, so that will tell me my jump values time, plus 1 times negative 16 plus 3 times negative 16. So let's graph that. And the first thing I notice on this graph is I just don't have enough space. So I'm going to change the axes. And you should always do that if you need to fit your graph. So let's fit my graph. Let's see, there we go. So I need a positive 80. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So I'm thinking if I make each one 10, that should be enough. So that means 8 is my 80. And I know my vertex is negative 2, comma 80. So there's my vertex. And it's going to be a little hard to do these jumps, but remember, it would be plus 1 times my a value, plus 3 times my a value, plus 5 times my a value. So I'm going to go right 1, down 16, which is roughly right there. And again, I have a symmetric point over here. To the right one, down 3 times negative 16, which is down 48. So that's 5, 10, 5, 15, 25, 35, 45, 48. So right below the 20 mark. Symmetric here. In fact, and that right below the 20 mark, in fact, is my 16, right? Because that's the initial height. And then over one, down 5 times that, so down 80. 10, 20, 30, 40, 50, 60, 70, 80. Way down here. So I've graphed my parabola, and now I need to determine what physically any of this means. Right? Because it's all great that it's just some picture, but what does it mean? More importantly, when does it get to its highest point? When does it hit the ground? All that good stuff. So let's zoom out and see if we can answer that question. So how high would it go? Well, does it really get up to 80, right? Because that's my vertex. My vertex is at 80. Does it get to 80? No. Reading this problem, it starts at my window at 16 and goes straight down. Theoretically, if I threw a ball a bunch of seconds earlier, it would have gone up to 80 and then started falling faster and faster and faster until it got to the point where it was at my window, traveling at 64 feet per second. So how high would it go? It would only make it up to 16 feet, which is as high as it starts. Because I'm throwing it downward. It can't go any higher if I'm throwing downward. At what point would it reach that highest point? Well, at time equals 0, right, at the beginning. Now, how long would it take to hit the ground? That's really where our algebra is going to help us and our vertex form is going to help us. So as you recall, let me shrink some of this down. Sorry, let me get it all. I'll just move it. There we go. So our vertex form was negative 16 quantity t plus 2 squared plus 80. And I'm going to solve when it hits the ground, which is when height equals 0. So 0 equals negative 16 t plus 2 quantity squared plus 80. So now I subtract 80 from both sides. Negative 80 equals negative 16 t plus 2 quantity squared. Divide both sides by negative 16 because I'm going reverse order of operations, and so I get 5 equals t plus 2 quantity squared. Now I take the square root of both sides, and I get plus and minus the square root of 5 equals t plus 2. And I subtract 2 from both sides, and I get minus 2 plus and minus the square root of 5 equals t. And that's in seconds. And now the question is, what in the world does that mean? Well, if I take the square root of 5, that's roughly 2.24. So really what I'm doing is I'm taking minus 2 plus 2.24 and minus 2 minus 2.24. So looking at that, this gives me 0.24 seconds, and this gives me negative 4.24 seconds. Now what do those mean in the context of the problem? Well, if I threw it straight down, is it going to hit the ground in negative 4.24 seconds? Well, no, it can't go back in time and have hit the ground. But what it does tell me is that one of the spots is that it hits the ground in 0.24 seconds, very quickly, in less than a quarter of a second. Which makes sense if I'm throwing it 64 feet per second straight down. Right, that's pretty fast. It's going to hit the ground really fast. So how long would it take to hit the ground? 0.24 seconds. Now keep in mind, the fact that it was seconds depended on the fact that my velocity was in seconds. Because if it wasn't, if it was in miles per hour, then that would have been hours if the distances were in miles. So you have to start using your units to know what the answer means.